Hi, this video is about solving problems involving harmonic frequencies on strings. So our first problem here, it says a certain inspirational and wildly popular physics teacher just so happens to play bass guitar. This teacher plucks a string which is fixed at both ends by the guitar, giving it a length of 0.86 meters. The waves in the string move very fast at a speed of 380 meters per second. While many harmonics are present simultaneously on the string, what is the second harmonic frequency that the string vibrates at? So the second harmonic frequency on a string is going to have two of these half wavelengths. And a half wavelength is, just a crest or just a trough. This makes one complete wave, and so this would be the second harmonic. So this is the kind of wave that we're looking at here. And then second harmonic, another way of indicating that is n equals 2. We are told that the length of this guitar string is 0.86 meters. So I'm going to label that as a capital L for length. And then we have one other piece of information. We know that the speed that these waves move back and forth at has a speed of 380 meters per second. So I like to label it like this so I have my mathematical symbols all in place, and that more easily lets me figure out what is the frequency. So I'm going to write my equation for the harmonic frequencies for a string that's fixed at both ends. So I know that we're dealing with n equals 1, so I'm going to write F1 for the fundamental frequency. Oh, excuse me, this is n equals 2. This is F2, second harmonic here. So often it's the first harmonic, I just forgot. So this is the second harmonic. We're going to substitute in all of our values. So n is 2, v is 380 meters per second, and then 2 times the length of the string here. And then we're ready to do some calculations. So I'm going to put all those into my calculator here, which I just have a spreadsheet. So I get 441.9, but I only need 2 significant figures there, so my frequency is 440 hertz. All right, let's do another problem like this involving standing waves on strings. So I'm going to draw a picture of a new standing wave here. And it's going to be representing a slinky wave. So this particular one, it's going to have a pattern that looks like this. Okay. And the problem says, using a slinky stretched to a length of 3.0 meters, 2 friends, Sophia and Joella, figure out that they can create a standing wave with the pattern shown below here if they shake the slinky up and down 4 times per second. Determine the speed of the waves traveling through the slinky. So I've drawn this pattern so that if you counted the number of peaks and troughs here, we have 5 total. So we have 1, 2, 3, 4, 5. So this is the 5th harmonic. N equals 5 in this case. So I'll write that here. We also are told that the waves are moving. Oh no, we need to find the speed of the waves. We're told the length of the string, or the slinky in this case, is 3.0 meters. That is the length. And then we're also told that the frequency is, it says they shake it up and down 4.0 times per second. So that's 4.0 cycles per second or 4.0 hertz. We want to know what is the speed of the wave. Okay, so to find that, we're going to have to use our equation again, but we might have to kind of rearrange it a little bit. So I'm going to write it over here. The frequency of the nth harmonic is n times v over 2L. I'm going to substitute in the things that I know. So I know the frequency is 4.0 hertz. The harmonic number we're dealing with is 5. We don't know the speed, but we do know the length is 3.0 meters. Okay, so with that information, I can now solve for V. This is what I'm trying to get out of this equation. So I need to basically undo all this other multiplication and division that's happening to it. So I'm going to start by undoing this denominator. So I'm going to multiply both sides by 2 times 3, and that's 3 meters there. So I'm going to do that to both sides. So that's going to be 2 times 3 is 6, right? So 2 times 3 meters, 6 meters on both sides. So 6 times 4 is 24. So that's 24 meters per second over here. And that's 5 times V. And then we're going to divide both sides by 5, the harmonic frequency. And so 24 divided by 5 is going to be 4.8 meters per second. So that would be the speed of the waves that are moving back and forth on this string. So that's all I've got for you in this video. Remember, the opposite of love is not hate, but apathy.